Let's take a look at uniform motion. The word quadratic here means that when we actually form this equation and then simplify so we have no fractions, we're going to end up with a quadratic equation, and then we're going to need to solve that. So here you are in your happy little boat in the stream, and here you are, and you've got a paddle and you're trying to paddle, and you're going upstream, and the current, remember downstream, the current heads in this direction where you are downstream, and when you're heading upstream you're fighting against that current. And so we need to remember that idea of whether the current is downstream going with us, or if we're trying to go upstream and we're fighting against that current. And then also think back to the distance, rate, time formula, where we know distance equals rate times time. And you can solve for time by dividing both sides by this rate. And when you do that, you get distance over rate. And if you solve for rate, you're dividing both sides by time, and that gives you then distance over time. And we're going to need that idea as well to solve these problems. So here's our problem for the day. A motorboat heading upstream. Please take a moment to read over this, write it into your notes, pause the video to do that, and when you're done, hit play, and we'll start solving. So we have a distance of 24. There's a river whose current is running at 3 miles per hour. Remember, that's going downriver 3 miles per hour. And the trip up and back takes 6 hours. Well, we need to organize our thoughts, so let's use a table. Here we go. The rate going upstream. We don't know how fast the boat is going, but when you're going upstream, you're forcing yourself against the current. So as you go forward, the current is dragging you back. So whatever your rate is, it's -3 for the current pulling you back. When you're going downstream, whatever your rate is, you get to add that 3 miles per hour because that boat is pushing the rate of the stream is pushing you faster downstream. Now the distance either way is 24 miles. And the time, what we're going to do is take that distance equals rate times time, and time equals distance divided by rate. So that means we have to take the distance, 24, divided by the rate, r minus 3. Yes, that's an r. And for the second one downstream, it's 24 divided by r plus 3. Our equation then becomes, because we know that the trip takes 6 hours both ways, so if we take upstream and add the downstream time to it, so however long it takes you to go upstream, however long it takes you to come back downstream, you add them together and they're going to equal 6. So we have 24 over r minus 3 plus 24 over r plus 3, and that's going to equal 6. Well, this function has fractions where variables are in the denominator, so we're going to need to multiply through by the least common denominator, and doing that will help clear the fractions. Well, the 6 has a denominator of 1, but the other two, r minus 3, r plus 3, is our LCD. Let's go ahead and multiply through by that least common denominator, r plus 3, r minus 3, and you have to multiply it by everything. Don't forget the right-hand side of your equation. And when you do that, now we're going to multiply and multiply here as well. Well, the r minus 3's divide out, so for the first term we get 24 times r plus 3, and for the second term the r plus 3's divide out, so we get 24 times r minus 3, And on the right-hand side, we keep everything. So let's go ahead and multiply those fractions out, the terms out. R times R is R squared. Sorry, I missed my R squared. And then R times negative 3 is negative 3R. 3 times R is positive 3R. They add to 0. And then minus 9. Let's distribute now the 24 here, and the 6 on the right-hand side. You get 24R plus 3 times 24, which is 72, plus 24R minus 3 times 24, which is 72. And on the right-hand side, 6R squared minus 54. Now, on the left-hand side, these 72s add to 0, positive 72 and minus 72. And so let's go ahead and rewrite that. 24 plus 24R, these two terms, give us 48R on the left. And on the right, 6R squared minus 54. Let's move all the terms to the same side. So I am going to subtract 48R from both sides. That is going to give me a positive leading term, which is what I prefer. All of these terms have something in common, so we can divide here by 2, or we could divide by 6, because 6 divides this, and 48, and 54. So let's divide everything by 6. 0 divided by 6 is 0. We can write that if it helps you. Every term, right? And so here you get R squared minus 48 divided by 6 is 8R, and 54 divided by 6 is 9. We now have an equation that's quadratic, and we need to solve that. So let's go to the next slide. Here's our quadratic. Factoring quadratics. The 9 has factors of 1 and 9 and 3 and 3. We know that because this last term is negative, that the factors are going to have different signs. Let's write that first step. How do we get R squared? The only choice is R times R. We also know that, remember, because of this negative sign, the factors have different signs, positive and negative. Now we have to decide what factors of 9 here are going to give us products that subtract to give us 8. So we look over here, it's not 3 and 3, it is 9 and 1, so that those figures, pieces, factors, sorry, we're going to go in here. The larger factor needs to be negative, so this larger product is negative. So this gets the 9, the 1 goes here. Check it mentally by foiling it very quick. R squared minus 9R plus 1R is minus 8R, and then minus 9. So that works for us, that's nice. The next thing we're going to do is use the 0 property. If 2, here we have factors, or terms multiplied together to give us 0, then this is 0, or this is 0. In other words, we can set them each equal to 0. That's called the 0 property. This is a binomial, not a term, and a binomial. Well, let's set them each equal to 0. R plus 1 equals 0. R minus 9 equals 0. Subtract 1 here. R equals negative 1. And on the right, add 9. And again, if you'd like, you can indicate what's happening at each step. Or you could actually write it out and take more room. Okay, now, we have to stop and think. The original problem was talking about a rate. For us, we cannot have a negative rate. We're going to throw that one out. What that means is that we keep this one, and the boat was traveling 9 miles per hour. and you're done. If you would like extra practice from your textbook on page 141, try number 25. You can also go view an example in your book, example 6 on page 139. And that's it.